All right, here we go. So writing and using mole ratios. So again, we're talking about this center portion of our diagram. How do we get from moles of one substance to moles of another? In order to do that, we need to write what's called a mole ratio. So for this entire section, we are going to talk about this equation, nitrogen plus hydrogen yielding ammonia gas. All right, remember the G's are gas. These big numbers in front are what's called the coefficients. So some vocabulary that's maybe escaped you. So looking at this, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. These big numbers, these coefficients in front, tell you the number of moles of that substance that you have. So we have 3 moles of hydrogen, 2 moles of ammonia, 1 mole of nitrogen. So based on that, then, we can write ratios that relate moles of reactants to moles of products. Just a quick definition of a mole ratio here. It's a conversion factor that derives from the coefficients of a balanced chemical equation interpreted in terms of moles. So it is a type of conversion factor. Continuing on with this then, in chemical calculations, mole ratios are used to convert between moles of reactants and moles of products. They can be used to convert between moles of reactants, or they can be used to convert between moles of products. So for this equation, we could do nitrogen to hydrogen, we could do nitrogen to the product, a reactant to a product, nitrogen to ammonia, and we could compare hydrogen to ammonia. So reactant to product, another reactant to product, a reactant to a reactant, we could do nitrogen and hydrogen, or we can't do product to product because we don't have more than one product in this situation. So 3 ratios here. 1 mole of nitrogen is the ratio of that to hydrogen is 1 to 3. 1 to 3. 1 mole of nitrogen, 3 moles of hydrogen. For every 1 mole of nitrogen, you need 3 moles of hydrogen for this reaction. 2 moles of ammonia to 1 mole of nitrogen. That's our product to our reactant. And 3 moles of hydrogen. If we compare that to ammonia, our product 3 to 2. All right, so we've got our reactant to reactant, product to reactant, product to reactant. 3 different mole ratios. Now, let's see what that would look like if we used it in a problem. So this is a mole-to-mole calculation. Basically, it's going to be set up like this here. Given number of moles times the mole ratio is going to get you the unknown moles. What would a problem look like? Here's our sample problem. How many moles of ammonia are produced when 0.60 moles of nitrogen reacts with hydrogen? So what was our given moles? 0.6 moles of nitrogen. That was our given moles. Times our mole ratio. What mole ratio are we going to be using here? We want to compare ammonia. It says how many moles of ammonia to, what did it give us? Nitrogen. Ammonia to nitrogen. That is going to be one of the hardest parts for some of you to figure out. What is it trying to find and what did it give you? Yes, the word hydrogen is in here, but it is not important in this case. So we want to compare ammonia to nitrogen. So I'm going to switch over here to a whiteboard. Here's that problem that or the formula that I'm giving you to kind of try to help you think about this. Okay. So now let's go ahead and write this out. Okay, given number of moles we said was 0.60 moles of nitrogen. All right, that's N2. And it won't let me do subscript, so I will come back and add that 2 in there. Label, label, label in this is going to be so important because now you are going from one substance to another substance. So if you don't label, your numbers are going to get very lost. So our given number of moles of one substance times our mole ratio. Now, we said ammonia and nitrogen. How do we decide which one's going on the top and which one's going on the bottom? If we look back here, we already did these ratios. We figured out that nitrogen and ammonia are in a 2-to-1 ratio, or a 1-to-2 ratio, 2-to-1, 1-to-2. The 2 is going to be with the ammonia. How do we decide if the 2 for ammonia is going to go on the top or if it's going to go on the bottom? Canceling units. Exactly. You've got to get your units to cancel. So we have nitrogen. It's basically on the top of an imaginary fraction here. You can imagine it over 1. So we know for our mole ratio, we're going to have nitrogen on the bottom. So we want our moles of ammonia on the top, which we have 2 moles of ammonia based on our mole ratio or our chemical reaction. Okay, and then on the bottom, can't see, here we go. On the bottom of that then we will put in our 1 mole of nitrogen. It's a 2-to-1. Okay, and go back and add those subscripts quick. They're not going to be perfect. Sorry, you guys. We're doing the best we can here. Okay, so then if you type that into your calculator, 0.60 times 2 divided by 1. Now obviously you don't have to do the divided by 1 in this case, but for some mole ratios you will have a different number down here. Think about if this was hydrogen and ammonia. It would be important for us to use the 3 and the 2. So start getting in the habit of just punching that in. All numbers are important. 0.6 times 2 divided by 1 equals, ooh, goodness, undo. Here we go. Equals, if somebody did that, you should get 1.2 moles of, units cancel, leaves us with ammonia, NH3. Easy peasy, right? You'll get it. If the mole ratios are tripping you up, though, really spend some time figuring it out. I've had people who get to the end of this chapter and they didn't understand mole ratios on day 1. They never figured it out, and so then the entire chapter confused them. So please spend some time trying to make sense of these mole ratios, where the numbers are coming from, how do you decide what's on top, what's on bottom, that kind of stuff. So again, that was the center portion of this stoichiometry island. We went from moles of ammonia. We used that mole ratio, those coefficients of our balanced chemical equation. We used that to convert to moles of substance B. So we just did this part right here. On a test, or like even once you get to college, you're not going to be given like this formula that I have given here, okay? You're going to have to mentally think through these conversions. Keeping this stoichiometry island for when you get to that would be a super helpful thing. I just don't think that they give you these kinds of cheat sheets in college. They're just like, yep, figure it out. Okay, so that is that middle center of the table. Let's go ahead and I'll stop this video and then pick up again with the next portion.